Hey everybody, welcome back to the channel. In this video, well, I think we should just bust a construction myth. One of the comments that I get the most here on YouTube, less so on Instagram, and we used to get it a lot when we were on the forums back in the early 2000s, is, hey dummy, you're not supposed to hang your sheathing vertically. It's supposed to go horizontally. Is that true? Does it matter? Well, in this video, we're gonna get into a bunch of the documentation from manufacturers, the code, special design provisions for wind and seismic, and the APA. Like, this is gonna be a roller coaster of fun. That's right. Well, it turns out all this information has been out there for a long time. We're even going to show you how to use Google to find the answer to your questions. Anyway, being kind of humorous. Well, this house behind me has all the sheathing hung vertically. In fact, I'm gonna take the camera, we're gonna go over there. I'm gonna show you that it's a specific manufacturer that manufactures tall wall sheathing. That's the brand name. West Fraser. We're in the high seismic zone D2. These are production builders. These are not low-end houses in this particular area. These houses are going to start at the 800s across. They're going to start in the 500s. But you're going to see that a lot of the engineering details are the same, but we're not going to really get into that in a lot of detail. This video is just, what were these guys thinking? Wait a minute. You know what I just realized? The first floor and the second floor are hung vertically and the gable's horizontal. I don't even know what to make of that. Anyway, let's head over there.
So first of all, I want to explain just a little bit of background. This video is not intended as a look how right I am and how wrong those commenters are. This is just, all of this information is available and we can find it. And one of the things that is really holding construction back is the whole idea that we are right. I'm right because this is the way I do it. And a lot of times when I engage with people online, it's like, here's the references. Well, I don't care what the references say. I know that. When I first started writing for the Journal of Light Construction, my editor, who was fantastic, I'm not a writer, and I told him, I want feedback and criticism. Make me better. Because I had nowhere to go but up, right? And so one thing that he said is, don't ever make a statement that you can't back up with a reference. That's all this is this is just increasing the knowledge for all of us. Now, we've settled this argument 30 years ago. This kept coming up on the forums back in like 2001, 2002. And all this information was available then. We just had to go searching for it. So there's really nothing ever that's new. And so a lot of times these discussions, they just come right back up online. So you notice here, we are on the APA's website, apawood.org. There are members to, in fact, let me just show you. If I go to About Us, who is the APA? It's the Engineered Wood Association. It's a nonprofit trade organization that works with its members to do testing, come up with standards, whether we're using I-joist, OSB subfloor, or OSB for wall sheathing. The APA does testing, as you can see there. And stay tuned because Timmy's got a trip that is currently being planned to go and visit some of the testing. Okay, so you can have an opinion and I can have an opinion, and then there's the testing. So let's get into it. Again, link in the description below. Here's the APA excerpt, wall construction, excerpt of the engineered wood construction guide. Wall bracing and sheathing. And if we scroll down.
Okay, before I get ahead of myself, notice footnote A, panel strength axis parallel or perpendicular to supports. So we see it right there in the APA. We're gonna see that reference throughout all of these documents.
We have some of the tables. You'll notice a bunch of similarities amongst the different manufacturers. So here is the instructions from LP sheathing, APA rated sheathing and structural one sheathing. Okay, so if we just, it goes over the installation notes, etc. Now notice here under wall installation, it says it may be installed vertically or horizontally. In horizontal installations, stagger the joints a minimum of 1 stud bay. Then it talks about gapping the panels. Okay, now this isn't unique to LP. Let's head over to Weyerhaeuser. I'll scroll to the top of the document. All of this will be linked below. So there it is. OSB-4004 technical resource sheet, floor, roof, and wall panel installation. Now, if we scroll down, we're going to see that the wording is the same. This document I was able to highlight. First of all, notice the picture, either vertical or horizontal. When we get to walls, what we're talking about has to do with shear and with walls, not floors, not roofs. Notice the highlighted text. We can place it either parallel or perpendicular. See figure 8, that's what we just showed. And then it talks about we might have to block the panel edges if we run horizontal, and we do here in seismic zone D2. If we do go horizontal, we need to stagger. We can't then stack all the seams, but they want us to stagger that by at least 1 stud bay. Our engineering says if your first panel is an 8 foot, the second one should be a 4 foot. That way, essentially, you're staggering by 1/2 the panel. Okay, so let's head over to Huber Engineered Wood's zip system. You see that we use a lot of that. And again, this video is not sponsored by Huber Engineered Woods because I'm showing you lots of manufacturers, but they do sponsor a lot of the videos that I post, and I do visit lumber yards to do speaking engagements for them. So that is all just to be completely transparent. I got nothing to hide here except my true height, which my driver's license says 5'7", but I measured it's 5'7 3/4. Anyway, shear capacity of wood structural panels, because you don't care about that other stuff. So the zip panels that you see on our houses are going to either be 7/16 structural 1 panels or struck 1 panels in either 4x8, 4x9, or 4x10. And that's true of whatever we use for OSB or zip. And I mean, the first time that we probably used 10-foot panels was in the late 90s, and it was pretty new at the time. Okay, so you notice that there is published data about the shear capacities, and I'm going to try to zoom in here because we're going to get into this in a little bit. Notice this section right here, the 2021 SDPWS, Special Design Provisions for Wind and Seismic. STIBWS, I think is how the nerds pronounce it. What happens is the mill gets certified, and this is true of APA stuff or TICO tested stuff. Once you have that certification, then what the engineer looks at is that panel now meets that rating, and then we can use, or he or she can use the data, not we. I'm not an engineer. I'm not smart enough. They use that data to then build out the details for our shear walls. Now, what about panel orientation? Because that's what we're talking about here. Right here. Boom. There it is. Either horizontally or vertically. So I think we're making the point pretty well that this is not anything new. It is actually in the manufacturer's literature, which ultimately comes from testing. You might be thinking, though, the strength axis is clearly stamped on the panel, and it's parallel with the long edge. So, hey, dummy, you're wrong. Well, in this week's episode of How to Use Google, let's just do this. Oh, wait, you might have noticed I've already done some of this. OSB Grade Stamp. What is on your APA grade stamp? So here's the West Fraser answer. So you notice that this is what the grade stamp looks like. And down here, number 11, strength axis. This is what confuses us, right? So what does it mean? Down here, the strength axis indicates the direction of the board that has the most strength. Ah, gotcha. When installing subfloor and roofing, the panels must be installed with the strength axis perpendicular to the supports. And if you've ever not done that, you notice how much spongier it is to walk on. But when we rotate to the rafters, trusses, or joists, it's much stiffer. Okay. When installing walls, the strength axis can run either vertically or horizontally to supports. Again, I'm going to put all the links to this stuff below. So then why is it that we want to install our sheathing vertically here? Like, why is it that Awesome Framers keeps not staggering their studs, number one? Number two, why do we keep running it vertically? 2 reasons. One is our houses are fully sheathed. They don't have to be fully sheathed to resist earthquakes or high winds. It all depends on where you're at, and when the engineer does an analysis of that building, the engineer will tell us really what we have to meet code. And remember, code has a safety factor. But there is a whole lot of benefits if we just go ahead and fully sheathe the walls. One, the siding can attach to it. And there's an APA note on that, like James Hardy Fiber Cement, LP Smart Side. We can nail right to the sheathing. We don't have to hit framing, even in high winds. So that's a benefit. Fully sheathing means we don't have any difference in thicknesses of the wall plane. That's easier. Fully sheathing our walls also tightens up the house, making it more energy efficient. Also, fully sheathing the house means that our engineers have a lot more flexibility when it comes to their design and calculations. And at $200 to $300 per hour, yes, we're paying for the extra sheathing and labor, but it significantly simplifies things for the engineer and ultimately us, and it leads to a more resilient building for the customer. Hopefully, multi-generations, right? Here's West Fraser's website. Notice their wall sheathing, tall wall, quake zone, windstorm. Basically what they have done is they've manufactured in custom long lengths to be able to even get up past our plate-to-plate measurement and get up to, like, for example, the center of the rim. What's the benefit of that? Well, if we go mud sill to the center of the rim, we can now start to eliminate hardware in high wind zones. That's pretty cool. So along these lines, something that Tor says in this paragraph that's highlighted is that he feels that the framer's time is better spent on taking extra care while nailing than staggering rows of blocking as shown in figure 91 to accommodate standard joints. Now, if we scroll, this is what that would look like on the backside. We have a row of fire blocking, and then we've just added blocking above and below. So think about what he's saying there. I think this is pretty profound. At a time when we're really trying to bring younger people into the trades and train them, the most important thing is to use the right panel. Don't overdrive your nails and nail to the proper spacing, because that's what the engineer has looked up in the code tables. And so when they spec 6 inches edge nailing, 12 inches field nailing, it's incumbent upon you and me to make sure that it's nailed at that spacing with the nails not being overdriven. It's far more important to get that detail right than staggering the sheathing. Additionally, if the engineer actually does need the extra strength, they can just have us tighten up the nailing. Maybe go from 6 to 4. That's almost no extra labor for us, and we get the same end result. Okay, something else I wanted to just point out before I quit, before the video ends, is the special design provisions for wind and seismic, SDPWS. Page 46. Basically, this is the testing. There's the American Wood Council. Was at awc.com or awc.org. Just Google American Wood Council. You can get the NDS there. A lot of the stuff that we just do as framers, we don't necessarily know where did this come from. We could check the NDS. And so the special design provisions for wind and seismic, it has all of this technical information in it. There's an example of the 2021. I actually think I paid for this. Again, I'm kind of a nerd. I like to read this. It gets into, it just gets into a whole bunch of nerdy stuff. But if you are somebody like me that just, we're a framer and we kind of like, here's an example too. Anyway, case studies, right? So you know what it turns out that there is a thing called science where in different universities and laboratories, they do testing on this. And after major disasters, engineers go in and forensically look like, how did this fail?
Okay, so here we are, Washington Wood Construction Wind and Seismic Code 2021. I just want to point out, there's a whole bunch of stuff here. Again, link in the description below. So here's a bunch of case studies on different diaphragm. You see how the sheathing is changed in orientation, staggering, etc. Then if we get down here, we get into some of the code tables. But I just want to point out the footnote. Notice the footnote number 6. Diaphragm resistance depends on the direction of continuous adjoining panel edges with respect to the loading direction and direction of framing members, and is independent of panel orientation. So I think we're getting the point here. If we scroll down to the next table, identical comment in number 6. And all of this goes right back to the APA.
One thing I wanted to note as well is Tor covers this blocking behind horizontal panel joints. And you notice here that if you don't block and you just run your sheathing horizontally, but no blocking at the panel seams, your wall has about 60%, 40 to 60% the strength of the wall that is solid blocked and the panels are run either direction. So just think about this for a second. For the criticism that we get here on the channel for our tallest wall with no staggering of seams, but all of our panel edges are blocked, for those that really make comments about how stupid we are and that insist on sheathing horizontally, most of them are not blocking the panel edges. So at the end of the day, our wall is significantly stronger than theirs. And one other note, and by the way, if you just look down, special design provisions for wind and seismic, he's linked right to that section. And so we could actually go right to this document and find that section that supports that. I think actually I was just there. I just wanted to show you the whole thing. Yeah, it gets into this stuff. Now, you might be thinking to yourself that horizontal sheathing helps to smooth out or flatten out our exterior walls. We've definitely heard that come up over the years. But like my good buddy Aaron Jones from Big Dog Construction said, we got to go visit those guys in Canada, Grand Manan Island, last September. He made a comment to me when we were filming together.
In my opinion, the best thing you can do for a straight wall, crown your studs.
Yeah, yeah, the rest of it is kind of like...
Now, I would argue, and I have a hard time believing that 7/16 wood structural panels actually help to smooth anything out. I think if we were to look at a wall with like a WRB on it and we didn't know which direction the sheathing was oriented, we wouldn't really be able to make a value judgment on that. So, crown and collier studs for the flattest wall. Now, the reason why we don't necessarily want to go horizontal is because in our seismic zone, we would then have to block all of the panel edges. Remember, the tables show us what the resistance is in, what is it, pounds per foot, pounds per linear foot, based on the nail spacing, and of course the sheathing itself. If we add blocking, that is extra labor that is unnecessary. Second, that is labor that is unnecessary. Second really is that when we add wood to the walls, that means we can't put as much insulation. And so really, why would we do that? Now, I do want to show you something in the pursuit of trying to be intellectually honest. We all have biases. I have a bias. My bias is this. It is simply just easier to install vertically because I can go plate to plate. And on really tall walls, I can order 8, 9, 10-foot sheets. I can maximize like where the block lines land, minimize waste, etc. Now, I want to show you something. I highly recommend buying this. This is Tor Madison Structural Engineer's book called Wood-Framed Shear Wall Construction. And I bought my version in the ICC, the International Code Council's, online store. I can't remember. You can also buy this off Amazon in the printed form. I just want to show you over here this particular document. He calls out that staggering horizontal joints in tall shear walls. I've highlighted here that shear walls with staggered panel joints will deform about 25% less than if we just go ahead and lined up the sheets as I show them. Now, some of us read that and we say, oh, it's 25% stronger. That's not what it says. It says it will deform 25% less. So let's just say that the engineer calculates that in the big earthquake, my wall with all the panel edges lined up, not staggered, but they all are nailed with blocking on the edges, it deflects 1/4 of an inch, which, by the way, is about all we need to be when we leave a job plumb, right? Within 1/4, 1/8 to 1/4. So if my wall deflects 1/4 of an inch, and you take the time to stagger the sheathing as shown here, that means that you have staggered rows of blocking. Guess what? Your wall will have deformed 3/16 of an inch. That's just not enough, in my opinion, to justify all of the extra labor. This is what staggering your sheathing actually looks like. It's not just that my 8-foot sheets on the first row are then offset by one stud bay on the second row. You notice that this example shows that the long edge is staggered just like a floor. So for those that say that you have to go horizontal and stagger, you're just not getting enough value out of that to spend the time, in my opinion. Because remember, the engineer has a safety factor built into their calculations. So one of the big things that we always do as framers is we whine and we whine and we whine about all the Simpson hardware and all the engineering, and everybody knows that they're all in cahoots. This is just a way for Simpson to make a lot of money, and this is a way for the engineers. They're just so dumb. They should have to work with me for a year before they go to engineering school. And then what happens? As framers, we look at that and we're like, I'm going to go ahead and put more nails in. I'm going to add more blocking. I'm going to do this. And really, we don't have any education to back that up. We just have feeling. That's up to you and your job site. For me, the whole point of this video is just to show why it is that our engineers allow this, that the code allows this, that our customers are not taking a penalty. Our walls are going to be more thermally efficient. There's going to be less nails, less wood, less labor involved. In the age of an attempt for resilient housing and affordability, this would be a step in the right direction, in my opinion. The whole point of my channel is just I'm 47 years of age. I started framing, my first summer full-time was when I was 12, 1989. I just am so thankful. I just loved this stuff from day one. And as I was a teenager and started reading the Journal of Light Construction, and as you start to learn, you realize there's so much I don't know. And now at 47, guess what I realized? There's so much more that I don't know. So if you are an engineer, please comment below. What did I get wrong? We'll have like a pinned comment with an errata, because I'm sure I got some things wrong. The whole point of this is this information is out there. We have good reason to trust it. This isn't just manufacturers saying, well, our panel does this. By being TICO tested or APA stamped, there's like an industry standard. So it doesn't matter if I pick LP sheathing, if I pick zip sheathing, if I pick Tolco, if I picked West Fraser, if I picked Weyerhaeuser, right? And that's why the engineer doesn't really call out the specific manufacturer. They call out the panel thickness and nail sizing and nail spacing. So anyway, I hope you enjoyed this kind of content. I should have made this a long time ago. We've been answering this question for so long. I actually wrote an article for JLC on basic shear walls. Go buy Tor's book. Go spend time at apawood.org, the American Wood Council. If you're interested at all in this stuff, why, just look to gain the knowledge. It's there. What do they say over at the Build Show? Know better and build better. I'm not a Build Show contributor, but I think I agree with that sentiment. Anyway, hit that like and subscribe button. Share the video with somebody. And again, if you are an engineer, architect, designer, framer, I would love to hear your comments below. And if you're just somebody that's kind of interested in this stuff, maybe as a potential homeowner, somebody that's looking to get their house built, let me know in the comments below, what kind of content do you want to see? Do you have questions that we could maybe do our best to answer? Or even better, we can find somebody to answer them, someone like Steve Basic Architect or any of the others. So I love you all. We'll see you in the next video. Thanks for hanging out, everybody.